Hey, hello everybody, welcome back to my channel. You're welcome back to the part 4 of our Python tutorial series for absolute beginners. In the last tutorial, we talked about the range function, looping, the for statement, and I gave a practice question. In this tutorial, we're going to talk about numbers in Python generally. Under it, we're going to talk about the integers, float, and the complex numbers. We are going to talk about the math operators, how to generate random number, the math functions, and the errors to watch out for as usual. In this tutorial, we're going to use the interactive environment, which I call the interactive development environment in the first tutorial. The development is not there, it's just interactive environment. It was a slip of tongue. The interactive environment or the Python shell is going to be effective for what we are going to be doing in this tutorial because it allows you to see your output immediately as you type in your code. For example, if we type in print, we are going to see the output immediately. And when using the interactive environment, you don't usually need the print function because it's without the print function, it gives you your output immediately also. So if you type in just 3, you are going to see your output. So in the second tutorial, we talked about values. We said they are the basic data a programs work with, and these data has data type. And in order to check the data type of value, we use the type function. So if you check in the type of 3 now, we are going to have something like this class int, and we said this int indicates the data type of this value. So in this tutorial, we're going to talk about 3 of these data types. We are going to talk about the integer data type, the float data type, and the complex data type. The float is also called the decimal. So let's get started. Integers are basically numbers without a fractional part. They can be positive or negative, and they can be as large as possible. The only constraint you have when you create an integer is the memory of your system. If your system has enough memory, your integers can be as large as possible. Numbers like 10, 20, 1 million, and so on are considered as integers. So far, they do not have a fractional part. So something like 10.3 is not an integer because of the fractional part. And as we said, in order to check the data type of all these values, we use the type function. But when we use the type function on numbers like this, then we see something like class int. Yeah, that's true because all these values are actually objects and they are an instance of a class. I don't know if that actually makes sense. So if it doesn't make sense, don't worry about it. So what you have to worry about right now is this word in the quotation mark, this int. This int indicates that this 10 has that type of integer. The int is the short form for integers. Apart from numbers with no fractional part that are considered as integers, numbers in binary, octa, and hexadecimal are also considered as integer. So binary numbers are prepended with 0b. So if you have 0b 1110, this is a binary number, and if we run this one, it's going to convert it to the respective base 10 number. So if we press enter now, we have 30. It's the same thing if we print it also. So if we print 0b 1110, we have 30. So and if we now check the type of this binary number ob1110, we are going to have the same thing we have with this 10 class int. And also, apart from these binary, the octa numbers are also considered as integers. The octa numbers are prepended by 0, 0, and that would be maybe like 2, 3, 6, 4. This is also converted to the respective base 10 number. And if we check the type also, we have type 0, 0, 5, 4, 5, 5, 5, 2. We are going to have class int. And the last one is the hexadecimal number, and it's prepended by 0x. If you have 0x 1, 2, 3, a 1, 2, 1, 2, 2. So if you press enter also, it's going to convert it to the respective base 10 number. And if we check the type also, we will see it's going to be type what is it called, type int. This 0b, 0o, and 0x can be, the x, b, and o can be in capital letters also. So we can have something like ob11110. That's going to be the same. And if you don't know, the binary numbers are the base 2 numbers, the octals are the base 8 numbers, and the hexadecimal are the base 16 numbers. When you print all these numbers, they are converted to their respective base 10 numbers. The integers and the decimal numbers or the floating point numbers are represented differently on the computer memory. The decimal numbers are represented as floating point numbers, and they have a precision of about 15 digits. Any number with a decimal point or with exponential or a fractional part are generally considered as the float, and it has what the float data type. For example, if you have 23.5, this is an example of a floating point number. And if you check the type of 23.5, we have float. So this is class float, which indicate these are 23.5 is of a data type float. Apart from these, also numbers with exponentials, like if you have 123 e minus 5, this is also an exponential number. If you press enter now, this is 0.00123. So this e means 10 raised to power and whatever number that is behind it. And in this case, we have 10 raised to power minus 5. If you check the type of this also, we are going to have float 123 e raised to power minus 5. You see, we have float also, and this e can also be in small letter. We can have 23e5. We have, even though it has 0.0, it's still considered as a floating point number. If you check the type of this also, now we have 23e5, we have class float. So anything with decimal part or this exponential e or the fractional part are considered as floating point number. These floating point numbers in programming has a little bit of quirk. The last number is sometimes kind of weird. For example, if you have 0.1 plus 0.1 plus 0.1, this is supposed to be 0.3. So if you print this one, I will see something like 0.30004. Like, where does this 4 came from? Another example is let's see, we have x is equals to 0.1. Oh, sorry, x equals to 0.1. Now let's use the for loop to increment this x. Let's say for I in range 9, for I in range 9, then what? Let's increment this x with 0.19 times. So that will be x plus 0.1. Normally this is supposed to be 10 because we have 0.1 here and we are adding 0.19 times. So this is supposed to be 1, sorry. So this is supposed to be 1. If we print x now, let's see what this gives us. We have 0.9999999. This is actually called round off error, and for most times it's not something you should worry about. But for scientific calculations that might need high precision, there are libraries you can use. And also this can introduce bugs to your program without you knowing. Like the first time I came across this one, I was looking for the bug in my program for like 30 minutes before I figured out that it was the round off error. It is advisable to use the round function when doing arithmetics with the floating point number. The round function allows you to round off the number to the next decimal place or a decimal place you specify. So let's specify a 2 decimal place. So this gives us our 1.0 that we are actually expecting. Now let's talk about the third data type, the complex data type. In mathematics, the square root of -1 is an imaginary number and is represented with I. Some fields like electrical engineering represent it with J. So this I or J is called an imaginary number. A complex number is usually represented with something like A plus BJ or BI. The A is the real part and the B is called the imaginary part. It is the part with the J. In Python, if a number is postpended with J, it is considered as a complex number. So if you have something like 3J, that's a complex number. And if we check the type, we have type 3J. This brings us with what? Complex number. If you have something like 2 plus 3J, this is, if you check the type also, we have type 2 plus 3J, we have type the complex number. You can convert a number from any of the previous data type we have talked about to a complex number using the complex function. If you have something like x is equals to complex, what's it called? Maybe complex 2. Oh, sorry. Complex 2. We have, if we print x now, we have 2 plus 0j. The 2 is taken as the real part and the imaginary part is 0j. If we check type x now, we have complex. This complex function takes in two arguments. It takes in the part for the imaginary number and the part for the complex number. We have complex, you see, we have the real and the imaginary. So if you pass in 2 and 3, 2 will be taken as the real part and 3 will be taken as the imaginary part. In order to convert from one data type to another, you use the int function to convert to integer, the float function to convert to float, and the complex function to convert to complex numbers. So if you have something like int 3.5 This int converts this 3.5 to the integer data type. And as we said, the integers are the numbers without the fractional part. So this truncates the fractional part. It truncates the 0.5. So the fractional part is removed. If you have something like int, what's it called, 3.44, the 44 is removed. And for the floating point number, to convert a number to a floating point number, like converting an integer to a floating point number, 0.0 is added to the end. Like if you have float 3 and this is converted to 3.0. Also, a string, we have not talked about string, but a string can also be converted to an integer or a float. If string that can be converted to an integer or a float has to be a number, like for example, if you have something like 5, though this is a number but it's a string because it's delimited with these quotation marks. If we check the type of these, we have type 5, we have something, we have this str. The str is the short form for string. If you use the int function on this quotation 5, we have ordinary 5 without these quotation marks. You can also convert it to a float, like float string 5. We have 5.0. You can convert from a complex number to an integer, like if you have int 5j. Now we can convert this to a complex number. Can't type error, can't convert complex to an integer. We can convert this complex to a floating point number also. Float 5j can convert complex to float. But you can convert any of these other data types to a complex number. So you can convert complex 3, that will be converted to a complex number. We have complex 3.5, that will be converted to a complex number. But I think you should be able to convert a complex string also. We have 5, I'm not sure. Yeah, it's possible. So we can convert any of these data types to the complex, but you can't convert from the complex to any of these data types. Mathematical operations can be performed on all these data types we've talked about, the integer, the float, and the complex. And in order to perform mathematical operations on them, we are going to need the mathematical operators. And these are the mathematical operators: the addition, subtraction, multiplication, division, exponentiation, integer division, and the modulo. The first 4 are common. They do exactly what you know they do. Addition adds, subtraction subtracts, multiplication multiplies, and division, guess what, divides. But multiplication by juxtaposition, like let's say x is equals to, we have x is equals to 4, y is equals to 8. Multiplication by juxtaposition, something like xy, is not allowed in Python. So this is xy not defined. In order to do multiplication, you have to use the multiplication x times y. You might be wondering why the exponentiation wasn't a caret like you are always known it to be. The caret is used for something else in Python. So the star is used for exponentiation in the Python, and the exponentiation operation is the same as in math. It's the same thing as raised to power. Like if you want to say 3 raised to power 2, we are going to say 3 star 2, and that will be 9. That's 3 times 3, that goes to 9. The integer division or the floor division, that's the math operator with 2 division sign, rounds the number down to the nearest integer. It rounds it down, not round up. For positive numbers, it behaves like the normal division, just that it removes the fractional part, it removes the decimal part. If you have 2 divided by 3, that's 0.666. If you use the 2 division sign, which is the floor division, the fractional part is truncated. That's the 0.666, and it rounds it down to the nearest integer, which is 0 in this case. And for negative numbers, it does something that you might not expect. So let's see, 4 divided by 3, we have it's rounded to 1. So if you use it on the negative numbers, we have minus 4 divided by 3, that will be minus 2. You might be expecting that to be minus 1. Well, is this supposed to be minus 2? Because we said it rounds the answer down. On the negative side, minus 1 is greater than minus 2. So it rounds it down to the nearest integer, which is minus 2. This operator has a lot of uses. We are going to see them later. The modulo operator, which is this percentage sign, returns the remainder from a division. For example, if you have 9% or modulo 3, we have 0, because 0 is the remainder when 9 is divided by 3. If you have 11 modulo 7, 4 is returned because 4 is the reminder when 11 is divided by 7. This operator is very useful and is one of my favorites. It can be used to check if a number is divisible by another number. As a number is divisible by number n when it leaves a reminder 0 when it's divided by n. Like let's say 4 is divisible by 2. So if you have 4 modulo 3, 4 modulo 2, we have is 0. What again? 9 is divisible by 3 as we've seen earlier. So 9 modulo 3 will give us 0. In fact, all even numbers when divided by 2 has no remainder, they have 0 remainder. So this modulo operator can be used to check if a number is even number. For example, if you have 2 modulo 2, that's 0. 4 modulo 2, that's also 0. So this can be used to check if a number is an even number. And for the odd numbers, when divided by 2 has a remainder of 1. So we have 3 modulo 2, that will be 1. So this can be checked if a number is even number or an odd number. Another use case can be seen if you wish to circle over like a clock. For example, if you wish to go 7 hours past 9 p.m., that's going to be 4 a.m. So if you have 7 plus 9 modulo 12, that will be 4. So there are other uses which you will be seeing in subsequent videos. These math operators can be combined with other operations that we've covered in previous video, like the repetition operation using the for loop. So for example, now if we want to sum up the numbers from 1 to 10, we can combine these math operators with the for loop to sum up numbers from 1 to 10. Let's say num is equals to 0. Let's say for I in range 1 to 11. Like we saw in the previous videos, this range function is going to generate a number from the start value to the last value minus 1. In this case, from 1 to 11 minus the step, which is 1 in this case, because the step value is defaults to 1. So it's generate a number from 1 to, what's it called, to 1 to 10. We have num is equals to num plus I. I'm going to explain everything, don't worry. We have print num. That's 55. So what's actually happening here now is that in the first line, num is given a value of 0. Then we start the for loop from 1 to 10, and in the first part of the loop, the I is equals to 1 and num is equals to 0. That will be num is equals to 1. That will be num equals to 0 plus 1. That will be 1. In the second part of the loop, we have num is equals to 1 and I is equals to 2. That will be 1 plus 3, and this continues to reach I is equals to 10, and that will be the sum of everything is going to be 55. In this same process, we can multiply all the numbers from 1 to 10 using this same process. Let's say num is equals to 1 for I in range 1 to 11. Oh, sorry, we forgot our colon. Let's write that again. For I in range 1 to 11, num is equals to num times I. Then we can say, okay, let's add the print function to see how this is done in sequence. We have print num. Then in the final part, we have 3608 362,880. So in the first part of the loop, num is given a value of 1, and we said, and the range function starts from 1, then that will be that 1 times 1, that which equals to 1. So the first one is printed 1. In the second pass, I is equals to 2, num is equals to 1. That will be 2 times 1, 2. In the third pass, num is equals to 2 and I is equals to 3. That will be 2 times 3, that's equals to 6. And this continuity will reach the last value. So let's say a shorter way to do this. Num is equals to 1, and for I in range 1 to 11. So instead of writing num is equals to num times 1, we can just write num times equals to I. This is a short form for num is equals to num times I. So if you are going to repeat the variable 2 times, we can just put the multiplication before the equal sign, and that is going to mean exactly what's here. And we can just say print num. Oh, sorry, print num, and that will be 362,880. You can also use this for the addition sign, like num plus equals to 1, num multiplied by equals to 1 is all the same thing. You can say num divided by equals to 1. You can use any of the math operators this way. The order of operations of the Python math operator is similar to that of mathematics. The exponentiation is evaluated first, followed by multiplication, division, the integer division, and the modulo operators. If you have a combination of them in an expression like this, they are evaluated from left to right. That is, 34 multiplied by 2 is evaluated first, followed by divided by 4, then modulo 4, and the integer division 4. After the multiplication and division, the addition and the subtraction operators are evaluated last. Also, if you have a combination of them, they are also evaluated from left to right. You can use the parentheses to override the usual order if you need to. For example, if you have 71 plus 98 plus 5 and everything divided by 5. This is evaluated it is evaluated as 5 divided by 5, then plus 98 plus 71. If you divide this on now, we have 170.0. In order to get the average of the three values, you use the parentheses to override the usual order. That will be 71 plus 98 plus 5, then everything divided by 5. Then we have 34.8. To make our programs more interesting, it would be nice to introduce some randomness into it. This randomness can be useful if you are creating games like Guess the Number game. The program generates a random number and we make a guess. Then the computer checks if you are correct or not. We'll be building something like this in our beginner project series. To generate a random number in Python, we use the randint function from the random module. Python includes many built-in functions already. Some of them is the print function, the input function, the int function, float type, and other functions we have been seeing. A program can call all these functions easily and make use of them. Some functions do exist in separate program called module. A module is a program that consists of useful functions and variables which can only be used by importing it. We won't talk much on importing in this tutorial. It's a topic worthy of having a separate video. In order to import the randint function from the random module, we use the from and the import statement. So it will be as simple as saying from random import randint. This randint is a short form for random integer. The random module has a lot of functions, but for now we only need the randint function, and the randint function has a structure like this, like randint a, b. It generates a number from a to b inclusively, unlike the range function. That is, the endpoint is included. If you pass in 0 and 5, it's going to generate a number between 0 and 5, with 5 also included. You can choose to give a value to one of its arguments and it will be taken as the endpoint, and 0 will be taken as the starting point. So if you pass in something like randint a only, it will generate a number between 0 and this value you pass as a. So let's say an example here. In order to generate a random number between 0 and 10, we just say, let's say we have random number as a variable is equals to randint 0 to 10. Then we print random number. The randint function is imported from the random module. You only need to import it once, and it should be done before it is used. That is, it should be done before you use the randint function. A random number is then generated from 1 and 10 with 10 included, and it is stored in a variable called the random number. It is a good practice to name your variable name with a name that describes the value that is stored in it. Then after we've generated the random number between 0 and 10, then we print the random number. If we run this one now, we have something like 3. That's a random number generated between 1 and 10. If we run this again, we have 10. If we run this again, we have 7. This randint function will generate a new random number every time we run the program. But there's a way to make it generate the same random number every time. But we are not going to be talking about that in this tutorial. So let's check again. Let's say we have 8 again. If we run it again, we have 10. In order to generate 10 random numbers, we can use this in combination with the for loop. Let's say for I in range 10, random number is equals to randint 1 and 10. Then print random number. What we are doing here is that we are starting the for loop with 10 numbers. That is, this is going to run 10 times. Then the randint function is called, and the value it generates is assigned to the random number variable. Then we print the random number. If you run this one now, we have something like, oh, that's an error. Name randint is not defined. Okay, that should be a single t. So if we run this again, we have 5, 4, 6, 7, 5, 8, 8, 4, 3, 1. That's a 10 random number generated between 0 and 10. There's also a math module that contains math functions that are not part of the Python built-in functions, like cos, sine, tan, log, square root, and the floor function. The math module also contains some constant values like pi and the e. Here's an example. Like we imported the random module, we are going to import the math module also. So that will be from math import. Maybe let's import the cos function, the pi, the square root. If you are importing, you can combine a lot of functions you want to import on the same line. If you want to print the cos of 0 now, you can just say print cos 0. If we run this one now, we are going to have the cos of 0, which is equals to 1. If you want to print the square root of 4, you can just say print the square root of 4. If we run this one now, we are going to have the square root of 4, which is 2. We can also use the pi that we imported by using it to find the area of a circle with a radius of 2. We have print, that will be equals to, the formula for finding the area of a circle is pi r square, and our pi is equals to 2. Then that will be pi multiplied by 2, which is our radius, and that will be square. Math operator for exponential is double multiplication sign. If we run this one now, we have 12.56666. In the Python built-in function, there are also two math functions there also. The absolute function and the round function that we saw earlier. The absolute function returns the absolute value of a number. For example, if we print the absolute of -1, that will be equals to 1. If we run this one now, we are going to have 1. And as we saw earlier, the round function round a number to the number of decimal places we specify. If we want to round 7.45 to 1 decimal place, now we are going to have 7.5. In order to view all the functions and variables in a module, you use the dir function. That will be dir. Then you pass in the name of the modules you are looking for, all its function. Then that will be like maths. Oh, maths is not defined. We need to import here also. Import maths. Then that will be dir math. So these are all the functions in the math module. We have asine h, atan h, the arrow function, the exponential, the gamma, and so on and so forth. Also, if you need help on any of them, Python has a built-in documentation to all these functions and modules, which you can access with the help function. For example, you can just say help math. Then let's see. So this is a help on the built-in function of math. So we have a cos returns the arc sign measure of x. This returns a value between 0 and 1. The a cos h, and so on and so forth. So you can always use all these functions that are already made for you. So when programming, it's not possible to be free from errors, and even the professional programmers make mistakes. So why isn't all these functions that we've covered and everything we've covered in this tutorial, these are the likely errors or the likely mistakes you should be wary of. The first one is that integers cannot start with 0. We can have something like 1, but we can have something like 0, 1. It's a syntax error. So you should be wary of this. The second one is a round off error we saw earlier. Like the sum of like 0.1 plus 0.1 plus 0.1, that will be 0.3330. For like, where does this 4 came from? In order to solve this one, it's better you use the round function. Whenever you are doing arithmetic on floating point number, you can just pass this to the round function. 0.1 plus 0.1 plus 0.1. Then we can specify the decimal place we want. That will be 2 decimal place. Then we have is 0.3. The third error you should be wary of is multiplication by juxtaposition. Something like where we have x is equals to 0.1, y is equals to 23. So if you want to do multiplication like z is equals to x open brackets x plus y, something like this is not allowed. That's an error. So you have to use a multiplication sign. So that will be equals to x multiplied by x plus y. That will be 2.32, 2.31. There's also an error which is a logical error using the integer or the float division or negative number. So this is not going to crash your program, but you should be aware that this float division round down to the nearest number. So if you have something like 5 divided by 2, we have 2. So minus 5 divided by 2, that would be minus 3, because minus 2 is greater than minus 3. This might not crash your program, but you might be provided with an answer you are not expecting, so you should always watch out for that. Another error that is common when importing modules is importing the wrong modules. For example, if you want to import the random module, it's random with a small letter, not random with a capital letter. So if you import something like a random, that's going to be an error. No module named random. So you should always be wary of this. Also, you should remember that the last number in the randint function is inclusive. If you generate a number between 1 and 10, the 10 will also be included, unlike the range function. As a practice question, write a program that generates a random number between 1 and 10 and prints your name that many times. That is, if it generates 5, it's going to print your name 5 times. The second exercise, write a program that asks the user for a number of seconds and print out how many minutes and seconds that is. For instance, 200 seconds is 3 minutes and 20 seconds. So you can use the float division operator to get the minute and the modulo operator to get the seconds. So you can submit your code in the comment section. Thank you for watching. Subscribe and turn on the notification button to get notified of future videos. I look forward to seeing your comments and recommendations. Like or dislike this video based on what you think. Thank you, and I'll see you guys in the next tutorial.